Okay, so what we just talked about was we actually talked about the introduction, we talked about the results section, we talked about the materials and the method and factors held constant. Part 1. Going on to part 2, and this is where we actually start analyzing. Now, this is really the important part. This is what I want to stress. Sometimes we can spend a lot of time on that first part of the prac report. This is the crunch of it. This is what you need to know. If you want to, this is a bit of a hint or a trick in order for you to save a bit on word count. You might want to actually put a heading description of results so that it's officially still part of your results section but doesn't have to count necessarily in the word count. You want to, in that, describe what the trend of that data is showing. You might want to comment on whether there's scatter or not. You don't want to say why at this point. You want to just be commenting on the raw results and linking that scatter, for example, to the R-squared value. You want to specifically refer to the data in terms of the different alcohol chain lengths and their molar enthalpy. You could talk as well about the observations, and so you actually describe your quantitative results and talk about that in terms of whether, for example, incomplete combustion happened or the degree of separation, the amount of soot produced, for example. Then we get on to the actual discussion, and in those we have the two sections, the analysis of results and the evaluation of the results. So you want to talk about, in your analysis, you want to talk about the chemistry of what is going on here. Again, this is a very, very important part of your prac report. Remember, you might have actually put your calculations for your description of how a transesterification reaction happens in your results by putting that a figure in there before you do your calculations in order to assist in your explanations of why you do your calculations the way you do them. So this is in general what you would do for analysis. 500 to 600 words where you're discussing the background or theory. Some of it might be going into the introduction. So what can you discuss? Well, you can be thinking about combustion reactions. You can think about your hypothesis and why did you think what would happen in the hypothesis, what you hypothesized, why you thought that trend would happen. Think about the number of bonds. Actually explain why you think that trend would happen, and you need to have a think about what we've done with biodiesels and what we've done in topic 4 to help explain that. Thinking about how the number of carbon atoms really links to the molar enthalpy of combustion. You can also refer to complete and incomplete combustion there, and you might want to link in soot, for example. Now remember, this is not discussing errors at this point, so you must need to be just talking about the chemistry involved. You might want to talk about dispersion forces. You might want to talk about enthalpy and how enthalpy is calculated. You might want to look into that a bit more. But you must make sure that you are putting chemistry into this section, obviously, and explaining why you thought what would happen in the trend would happen, and then saying whether the results actually support this or not, or whether the data is inconsistent due to the effects of significant random and systematic error. Then you move on to the evaluation. Do try, and when you do that, to make sure that you do follow this. And this is something I, at least, have noticed in some of my classes, is that we're not still following this format. You can choose to put random or systematic first, doesn't matter, but you must get some of these things right. Random error links with precision, systematic error links with accuracy. You must start by referring to the data and indicating whether there's evidence of random or systematic error during the data. So if we started with random errors, are they present in the data? Now, if you're thinking that you're going to go with random error, if you think that's more of an impact on your results, then you want to put that first. You might want to comment that it's likely to have had more effect. So you could discuss 4 errors potentially, or 3 to 4 errors. Make sure it's 3 to 4 errors. That would be important. You want to discuss it. Why is it a random error? What effect does it have on the data? How do we see this effect? What improvements could you make? Number 2, why is it a random error? What effect does it have on the data? How is this shown? What improvements could be made? Please follow that. Make sure you talk about improvements. Systematic. Talk about the data, whether it's viewed in the data. Link it to accuracy. Then error 1, why is it a systematic error? What's the effect it's going to have on the final values? What improvements could you make? If you do have word count, you can add a little bit on the end listing more minor errors, but you do not have to. You do not have to, so don't think you have to. Then we're finally going to end with our conclusion, and we want to summarize the findings. We want to say whether it's supported the hypothesis. You might just have shown partial support, for example. You want to say if it's supported by current literature, and you want to also include that. This is important. You want to try and link to current literature when you're talking about in your analysis. That would be really good in your analysis, at the start of your analysis, to talk about, when you're talking about the trend, whether that is supported by literature. Is it valid? And remember, that is, we determine validity by whether the procedure used is a well-known and accepted method. And then you can sort of summarize the fact of, if there is significant random and systematic error, you're going to have precision and reliability. Remembering random links to precision, and reliability also sort of links to random. Then you can think about the limitations around the experiment, and we talked about this with your first prac, but what are your results limited to? What are they constrained to? Is determined by what you've actually measured. And you therefore determine what would, from your prac, be the most efficient biodiesel. So I do hope that helps. Now, the tricky bit always, of course, is thinking about what is the errors that are involved here. And you just need to really have a think about everything that's involved, all the equipment that's involved, all the potential ways in which you could have had errors. I'm not going to actually go and give you too many hints around that, other than thinking about all the equipment involved and the little steps you did, and really picturing that and thinking where little errors could have come in. I also really want you to dig deeply into why we did each step, because that's going to also help you, if you know why you did each step, think about where errors could have come in. I hope that helps. Of course, you can come and ask questions if you need a bit more assistance with how to write up your final prac report. Good luck.